Hello everyone, today in this video we'll be discussing the fourth module of system software, and let me tell you that fourth module is a different module than the other modules. Why? Because in the previous year, in the previous schemes like in the 15th scheme and the 17th scheme, we did not have the topics which are mentioned in the fourth module, and this is the third textbook. Okay, totally there are 3 textbooks. In the previous schemes only 2 textbooks were there. Here in this scheme we have 3 textbooks, so it's hard to find out the questions which are appeared in the previous papers because there are very few, and it's hard to means get the trend and the pattern of what type of questions are asked. Okay, so keeping these things in mind, I'll be discussing the topics of the module 4 of system software, and I'll be directly showing it from the textbook because that's the best option available. Notes are waste because in notes we don't get the whole picture of the thing, so for system software textbook is the best thing. Okay, and yeah, let's get started, and I'll be discussing according to the modules. Like for module 1 and module 4 the textbook was the best. Okay, and for the remaining things, let's see what are the best options available to us. And if I show you the important questions which I got from some resources, this is the textbook. Okay, we'll be discussing from here itself, and before that I'll be telling you what are the chapters. Okay, totally how many chapters are there in module 4? In the module 4 we have 3 chapters. Okay, 3 chapters are for what? One is for Lex and Yacc. What is the basic definition of Lex and Yacc, where it is used? Second is just the depth information about the Lex, and third one is depth information about the Yacc. So what is Lex and Yacc in layman's terms? Lex means words. What like for example, if you have words written here like apple and application, and you have ant. Now what you have to do is you have to find out which letters start from A and have double P in the next 2 letters. This is the pattern which you have to find out. So this is the pattern which you will define and then search in this text. This is the text which has 3 lines, so you'll search this text in this one. That is the work of Lex. Lex, what it will do, it will search and match the patterns. It will search and what? Match the patterns. That is the work of Lex. Now the work of Yacc, what it will do is, after the texts are coming, like different text matches will come, after that it has to form a logical sequence between them, like which order it should be so that it forms a meaningful sentence. That is known as Yacc. Okay, so these are the 2 things which we will be learning. Okay, already we have learned in the lab things what is the format of it. For example, for both Lex and Yacc, this is the format. Like this you will be writing and starting, and yeah, this is the definition section. Then we have the rule section, then you have the user defined functions, those section, right? So these are the 3 sections available with us. So we'll be diving deep into the 3 sections and what are the things which are possible in each of these 3 sections, the syntax of it and the possible codes. We'll be discussing the differences between Lex and Yacc, very important question from exam point of view. We will be also discussing what is the difference between the handwritten Lexer, which is in C, and the Lex, which is in Lexer. What are the differences, which is better one? So we'll be discussing these things. These are the important questions from exam point of view. Also, we'll not have much numericals here. I don't think so any numerical is there. Just the theory parts and the programs. Okay, program number 1, 2 and 6 from the lab, very important. Okay, have to learn this one for this module. It means in exam they can ask you directly. I'll show you the questions which are important questions. I tried to fetch how much I could. So let's see what are the functions, I mean what are the questions. So these are the topics. We have 3 chapters. This is chapter 1 and chapter 2, this is chapter 3. Okay, these are the topics. Textbook 3, chapter 1, 2 and 3. And these are the important questions. Okay, how many? 12 are there. So if you go through the questions, you can easily observe that what they have mainly are focusing on your understanding of Lex and Yacc programs, right? The syntax of it, the structure of it, and your ability to write the program. You should know how to write a Lex program and a Yacc program for a given context. That's what the main aim of this module is. Module 4's main aim is to make you aware of what is Lex, what is Yacc, what is its syntax, and how to write the code given a question. Okay, that's all what they are checking. So with this mindset you have to approach further in this video. Fine. The first question, explain the structure of Lex and Yacc program with an example. Okay, next one, Write a Lex program to identify the parts of speech. Parts of speech means verb, adverb, preposition, conjunction, noun, and adjective, so on. Okay, these things you have to identify. Then you find symbol table. What is a symbol table in layman's terms? Symbol table means it has symbols and the corresponding values for it. Okay, whenever it reads some input and it finds a new word, it will attach, it will insert it in the symbol table. Explain briefly parser-Lexer communication. Lexer comes first, it will search for the patterns, and parser, it will pass the tokens and the means individual items to the parser. Parser will make a logical sequence of it. That is the parser-Lexer communication you have to explain. Differentiate between Lex and Yacc. Very important. What is regular expression? You're just defining rules to match a pattern. That's what regular expression is, isn't it? And then we have write a Lex program, Yacc program to identify a power n b, which is nothing but lab program 2. Write a Lex program to count the number of command lines and output the command lines in a separate file without means without the command line the output should be shown in the separate file. That's lab program 6a. And here we have the Lex and Yacc program to count the keywords and identify operators, that is lab program 6b. Okay. Also there is another question which is word count program, shift-reduce parsing. These are different methods of parsing. Also recursive parsing is there, but this is more important. What do you mean by eliminating ambiguity? How do you eliminate ambiguity? The techniques you have to discuss. So you got a brief idea, right, what you have to focus in this module. Okay, so let's get started with the textbook, and I'll show you what are the chapters we have to focus on. As told before also, what are the chapters? Chapter 1, chapter 2 and chapter 3. Chapter 1 is mainly concerned with the Lex and Yacc. Okay, this is the first chapter. So it will just briefly discuss what is Lex and Yacc and what are its means top view of Lex and Yacc, what it does. Okay, not details. Then after knowing the brief overview, we'll be diving deep into using Lex programs, means Lex, how to use, and how to write the Yacc. Lex is for the R for something was there, right? R for, yeah, regular expression. Okay, Lex is for regular expression, Yacc is for grammar. Okay, so let's get started with the first topic, Lex and Yacc program. So let's go to that part. Here's the chapter 1, and here what they have given is about the lexical analyzer. What is a lexical analyzer or lexer or a scanner? Specification, lexical analysis. What does it mean is you have a code here. Okay, these are important things you have to note down. Okay, note down this first thing, which is what is lexical analyzer. You have to start from here. Okay, introduction. First thing you need to know what is Lex and Yacc. Second thing, what is lexical analysis? A text of code dividing into a separate tokens. That's what lexical analysis is. And who does that? Lexer does that, or lexical analyzer does that. Okay, so the token description that Lex use are known as regular expressions. So after we have made tokens here, the tokens will be matched in separate groups, that is found by regular expression. This regular expression will match these tokens, and this regular expression will match these tokens. Okay, so that's the second point you need to keep in mind. Then after the tokens are identified by regular expression, they are passed to the parser. Parser will make the means sense of out of it. Means these are individual parts, how are they related with each other? That will be done by the parser. Okay, for that we'll be using grammar and writing the Yacc program. Okay, so that's what they have mentioned in the first topic, which is introduction to Lex and Yacc. Then the simplest Lex program. How does the Lex program look? It looks like this. Okay, percentage, and in between we have to write the logic part, and here also the ending part, percentage. Okay, so what it does is it copies its standard input to its standard output. See, observe carefully what's happening. Here we have three things: dot, bar, slash n. Dot will match everything except slash n. Or means or. Slash n means it will match slash n as well. So this will match everything. Echo means what? Whatever has matched, echo it into the screen. Means it will display into the screen. So what does this line of code do is, whatever the input you give, that will be the output in the screen. Okay, that's the simplest Lex program, and that's what is there in this topic. Then the next topic is recognizing words with Lex. Okay, so here starts the important discussion of the final program which is identifying the parts of speech. Very important question from exam point of view. Okay, so from now only listen carefully what are the things I mentioned, keep in mind. Okay, so here we have the recognizing words with Lex. So here what they are doing is, let's build a simple program that recognizes different types of English words, and different types of English words can be like, it can be noun, verb, adjective, adverb, pronoun, conjunction, and so on, right? So we'll identify the different kinds of English words, different types of English words, and classify them. Okay, so here are a set of verbs given to us. Now what we'll do, if any of the word appears in this means group of words, it will be called as verb, else it will be called as not verb. Okay, so I'll be giving an input here, a large number of words. So each of this word will be checked if it's present in this list or not. If it's present, it will be called as verb, else it will be called as not verb. So how to write a Lex program for it? Firstly, we need to tell the compiler these are the words which you need to check for verb or not. So that one will be telling to the compiler. How do we tell it to the compiler? This is the definition part. Here we need not have anything, just the rule part we need to have. So in the rule part, let me show you the whole rule part. It ends here, and where it's starting from, it's starting from here. So let's discuss each one by one what's its meaning. Slash t plus, okay, see here, slash t plus. Slash t plus means slash t, it can appear one time or n number of times. If it appears, what we have to do? Nothing, just this is matched and nothing is specified here, means it will not do anything, it will just ignore it. Okay, this is a semicolon at the end, means if you find, you find, that's it, move on. Okay, don't do anything. Then what we have, these are the letters, I mean words, is or, am or, are or, and by using the bar here we are writing all the words. If it matches any of these words present here, at that time last word is go, and after that what is the thing which has to be done? Printf percentage s is a verb, and what is percentage s? It is shown as YY text. So whatever is matched, it will get stored in YY text, and that will be shown as it's a verb. For example, if I input as could is a verb, that output will be shown. Okay, so that's what should be done if any of the word here appears. Now if suppose that it was a word like xy, xy did not appear here, right? So what will happen? It will come to this part and it will check if it xy is present here. Yes, it's a part of a to z here. So what it will do, xy is not a verb, that it will print. If it's not even that, like for example I inserted 9, that time what will happen, this will be matched, echo, just echo it as such, like 9 is neither a verb nor not a verb, right? It's a number, we cannot compare numbers with is it a verb or not, it doesn't make any sense, right? So it will just output as 9. Okay, that's what the rule part. How many rules are there? 4 rules are there. Ignore the tab spaces if it's any of these words. Printf that it's a verb. If it's any of the other words, print it's not a verb. Finally, if it's neither of these three, then echo as it is what you have inserted. Okay, then coming to the main part here, in the main function we are calling vylex. So because vylex is the function which reads the input and does the lexical analysis. Vylex will read the input and do the lexical analysis. So let's see an example what happens when you run this program. Did I have fun? Is did a verb? Yeah, that's present in that list which I shown you, so it is a verb, it will shown. I is not a verb because that was not present in the list, so it will show as I is not a verb. Have is a verb because it was present in the list, and fun is not a verb because it was not present in the list. Okay, that's what the function is. Also at last you can see you have inserted question mark as well. It does not match the words, so it will just output as such. It will not say anything, it will output as such. Question mark will be output as question mark. Okay, so that's what they have explained here in the this part, whatever I just explained. And yeah, that's all what is there in here. Let's see what is there after this. Okay, we expand our first example by adding the recognition of some other parts of speech. Now since we have done for verb, why not we add for other things and see how it works for other things. Like for example, for verbs we did, right? This for the verbs program. Now if we want to find out if it is an adverb, we'll add few more words if it matches this one. See, if I like give an input like angrily, okay, so it will come and search here angrily, it will not get, it will come here. In the previous case it was coming here and output angrily is not a verb, but now I want to search if it's not a verb, what if it's a adverb. At that time I have to output it's a adverb, right? It will be more detailed. So I'll check if it's present here or not. If it's present, I'll output as it's an adverb. Okay, so that's what we are doing here. Same goes for few more words for preposition, few more words for conjunction and adjective, pronoun. If it does not match any of these, then write it as it might be a noun, because noun can be name of the thing, place, animal, and name, place, animal, thing, right? So it can be that name, so all the names cannot be mentioned in the program, it will be very big program, so that's the limitation. So that's why I'll just say it might be a noun, it might not be a noun, both is possible. If it's a number, definitely it's not noun, right? 9 is not noun, so it will output as whatever you inserted. Okay, inserted. Okay. Then after you have written the rules part, user defined function, you'll write pi_lex to start the lexical analysis of the input you provided. Okay, so this is the important question from exam point of view, the parts of speech program. Okay, so note it down. Then we have the next important topic, which is symbol table. What do you understand by the term symbol table? Symbol table means what? There is a table, there is a symbol. Each symbol has an associated value. So whenever I encounter a new symbol in the input text, I'll add it here and assign some value. And these values will be used for addressing and referencing purpose. Okay. So noun, verb. Symbol table will have these things: dog, cat, horse and cow, chew, eat and lick. So that is the symbol and these the values. Okay, and you have two operations here, very important: add word and lookup word. Add word is to add a new word to the symbol table, lookup word is for checking if that word is present in the table or not. And yeah, that's all what is there here. And Lexer with a symbol table. So this is not important from exam point of view, but you can go through it. Just get a brief overview of what's happening here. Lookup is equal to 0. Initially it will be 0. If it is verb, adjective, adverb and noun and all, it will change. Okay, so instead add word and lookup word. Okay, just get the brief top overview of what the things are. Okay, what is important I'll tell you. For that you need to focus more. Okay, let's move on. See here, state is lookup initially. If it is /n, means if nothing is there, state is equal to lookup, which is 0. Else if a verb appears, or adjective, adverb, noun, preposition, pronoun and conjunction, the state will be defined according to that. Okay, and then we'll be checking the switch case. If it's means what case it is, what state it is, based on that we will be outputting it is that case. Okay, and yeah, we are just means making the program more efficient. What we have written in the previous case, we are getting more efficient here. Okay, by using the struct word and star and all, will make it more efficient. Not worry much about this one, this is not asked in exam much. And here's an example. So after defining those things, if you write this example, it will classify it as follows: noun, verb and noun and verb is written here. Then if you write dog run, dog comes in noun, so it will output as noun. Run comes in verb, it will output as verb. So that's all what is there in the Lex part. So it's just a brief information of what is Lex and Yacc in the first chapter, right? So what you have learned in the first chapter. What is Lex? It recognizes the regular expression patterns and then outputs what is the pattern which I have found. That's what the job of Lex is. Okay, and it uses the lexical analysis, lexical programs. Okay, important question is that the program which is parts of speech program. Okay, so make sure you learn that. Grammar. What is a grammar? Grammar means rule. Okay, so here's a list of simple sentence type. Okay, so let me tell you: Ben plays. Ben plays. This is a sentence, right? Or Ben plays football. This is also a sentence. So Ben is a noun, place is a verb, football is a noun. So either this can be a valid sentence, or this along with football also can be a valid sentence. So these are two rules defined for defining a sentence. So grammar also does the same thing. It will define some rules, and whatever matches to that rule, that is the valid grammar. Okay, it's very similar to regular expression. Okay, so here we have subject goes to noun or pronoun. Okay, so how is subject used in the sentence? I'm not sure. So let's assume it's used like object, subject, object. Okay, I'm not sure about this. Just for example, I'm telling object, sure, object, subject, object. Okay, and subject can be either noun or it can be pronoun. So how to define this rule? The defined rule will be as follows: subject arrow means it can be noun or pronoun. That's how you define. And how do you define sentence? Subject, verb, object. So each will be checked. Subject can be either noun, pronoun, verb can be verb, object can be noun. So everything will be substituted as follows. Okay, that is known as the grammar rules. That was about the grammar, a brief information. And next we have the parser-Lexer communication, very important. So two steps. This is the input. Lexer will do the lexical analysis of it. Then we have the parser. It will make the sense of the tokens generated from it and make the means check if the syntax is correct or not, or if it's a valid string or not. Okay, that's what grammar does. It will check the logic. Okay, that's what the parser-Lexer communication basically is from the top view. And let's see what is there further. Okay, so see if you are player A, there is another player B. Okay, you both are playing one game. In that game, some codes are there, and B also has some codes. These two codes should be same. Then only you both will be a team, right? If you have different set of codes, B also have different set of codes. You both cannot communicate, right? Suppose B is from France, we are from UK. You know English, he knows French. You cannot communicate. So you need to have a common thing in between. So that common thing is the tokens codes, token codes. So you have to define the token codes as follows: noun, pronoun, verb, adverb, adjective, preposition, and conjunction. For these things, there should be a common code. Example: hash define noun 257. Wherever 257 comes, they both will understand it's a noun. Like that, we'll define for each of these. Okay. And if it is not matching any of this, it will return as 0. Okay, that's the default return statement. Okay, then the parts of speech lexer. Parts of speech lexer means the parts of speech was there. We defined what is the parts of speech. For that, how the lexer works. Okay, so we'll now build a lexical analyzer to be used by a high level parser. Hash include y.type.h, token codes from the parser. From the parser, the token codes are generated. Lookup is 0, initially it is 0, int state is defined, so 3 variables are defined. This is the header files and this is the variable. Then if it is /n state lookup, we already discussed these things. It's just in a more efficient format. And here we are the switch statement as follows. Okay, the same thing just written in a better way. Okay, so there are several differences here. We have changed the part of speech names using the lexer to agree with the token names in the parser. Also added return statements and few more efficiencies. Okay, but the logic remains same. Okay, see, we are writing return verb, return adverb. So these things will be substituted with the corresponding values like 257, 258 and so on. Okay, that's what the difference is shown here. And Lex is a program which gets executed, which reads the input, performs the lexical analysis. Okay, so end of the sentence can be /n or dot. So for dot it is this one, or /n it is this one. State is equal to lookup, return 0. When it returns 0, it is the end of the sentence. Okay, then we will see what is a Yacc parser. How do we write the Yacc parser? For Yacc, what happens? This is the Lex, this is the Yacc. Lex generates the tokens and passes to the Yacc. So what does Yacc expect initially? To get the tokens. So we need to define what is a token. For that only, there is a definition section. After that, we are writing token. Token means the value. 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 Token means the val Token can be either noun, pronoun, verb, adverb, adjective, preposition, conjunction. See, very simple. Here you have the English text here, and lexical analysis will generate the tokens, different parts. Means each word will be either noun, pronoun, verb, adverb, adjective, preposition, or conjunction, and this will be passed to parser. So parser can expect any of these tokens. So that's what we are defining here. Then sentence is defined as subject, verb, object, and subject can be either noun or pronoun, verb is verb, object can be noun. So this is how you define a grammar, right? Remember in automata we did the same things. A goes to A, B, B goes to B, C, so C also goes to somewhere. So like that we are defined. Same thing, sentence goes to subject, verb, object, subject goes to noun, pronoun, object goes to noun. Okay, then if it's in this format, it's sentence valid, else it's not. Okay, and we'll be reading it from a file. So we have created a file variable star yy in, and we'll parse it. So for the Yacc program we have to write yy parse instead of yy-lex, because lexical analysis is already done, we are parsing it, so obviously you have to write yy parse, isn't it, right? So after you have done that yy parse, then what you will be doing, while file is not end of the file, while feof means file end of file. Okay, while it is not end of file, at that time do yy in, take the input and perform the operations. And yy-rs is defined for this one, and for yy-lex it is, for lex programs it's yy-wrap. Okay, that you have to define for each of these programs. Moving on, what we have, this is the same thing which I just mentioned, the different parts of the program that's just defined here for the Yacc program. Rule section, you already know what is rule section. Between the double percentage signs we are defining, those are rules. And yeah, third final section, which is the user subroutines, which is at last you'll write main function, wrap, error, those things are the rule section, user defined section. And this is a program for extended English parser, so just a more efficient version of it. Okay, like we just included a sentence, now we have simple sentence or compound sentence. So these two are also defined in a similar way. Okay, just extending it to more efficient versions. Okay, same thing, just in a more efficient way. Okay, running Lex and Yacc. Okay, this you can refer the lab videos and all, there I have explained what is the exact code. Here I did not understand properly, so I guess these are the different versions, so that's why, but it's just for information, not asked in exam. So let's move on to the next topic, Lex versus handwritten Lexer. This is important. What is handwritten Lexer? C program. C program is what? Handwritten Lexer. Lex is what? Lexer written Lexer. Okay, the Lex program written by Lexer is Lex. The Lex program written by the hand or the user manually is the handwritten Lexer in C program. Okay, and you need to keep in mind that the Lex version is the third length of C Lexer. Means if C Lexer is this much, the Lex program will be just 1/3 of it, and it will take 1/3 amount of time, to debug and write the program. Okay, so let's see why it is such. This is a C program. Have a look at it. You have defined the things here, and we have main function, you have the Lexer value defined, and after the Lexer function is defined, we are checking if C is EOF or not, and the comparison is done, and many redundancies are present here, which will be overcoming via Lexer program. The same Lexer can be written as follows: define here, very small, patterns are defined, and here we have the main function. That's all, just once we'll call, no redundancies. Okay, that's what the difference between Lex and handwritten Lexer program. Fine, that's all we need to keep in mind. Okay, and yeah, that marks the end of the first chapter, which is a brief information about the Lex program and the Yacc programs. Okay, now we will see the remaining two chapters, in-depth information regarding Lex program and in-depth information regarding Yacc program. Okay, so let's get started. So the second chapter, using Lex. Okay, so you already know what is Lex. We discussed quite in depth what is Lexer, what it does. It generates lexical tokens from the input, passes it to the parser, right? So let's see what is there in this chapter. Regular expressions, you already know. Automata, same thing. It can match a single character except new line. It matches 0 or more. It matches the range. I need to explain this, right? Caret and the dollar, starting and the ending, it matches. It is the number of times it should repeat. Slash is used to remove the inbuilt meaning of it, 1 or more, and 0 or 1, or it can match a particular string, and it matches the preceding character. And here's a group, and it matches the group. So mostly used are the top ones, the bottom ones are not much used. So if you know the top ones also, you can easily write the regular expressions. Okay, so examples of regular expression, very simple. You know already what these things mean. Let's study in automata the same things. And for the number, for defining a number, this is the regular expression. If we quickly see what are the things present here, let's divide these things. Okay, this is the number, normal number. What we are doing here means we can just write 9, or we can have n number of 9s after that, or any other number also, like 3, 2, 1. After that we can have a decimal point as well, and after that we can have one or more points here, like 0 or 0, 1, 1. Then we have the exponent also, like e minus or plus 3, like that. So this is the regular expression for the number. This also we are discussing in the previous semester. Okay, here we will define the rule. After that we will echo if we find out the pattern, and we'll call the v.Lex here. Okay, very simple one. Just here, what is the things? There is actually nothing much in the chapter 2, just the lexical analysis, some examples, and word counting program is important. So let's see what is in the word counting program. Here we'll count the characters, count the number of words, count the number of lines. Okay, so let's see how to count the number of words, lines, and characters. So the rule section contains the patterns and actions that specify the lexer. Here is our sample word counts rule section. Here's the rule section. If it's a word, then word count plus plus, character count will be plus is equal to yy length. Yy length means yy length. Means suppose that I found out a word apple. So in apple, how many words are there? Apple is just a single word. How many characters are there? The length of this, which is 5. So character count will be plus equal to the length, and word count will be plus 1. End of line, character count plus plus, line count plus plus. End of line will denote the line has ended, so it will count as one line, and the end character is slash n, so another character will be plus plus. Okay, so if it's neither of these, just a letter, that will be character count plus plus. Okay, that's all what is in the word count program, and we'll make it more efficient by adding few more things. And here is the v.Lex to read the input and do the lexical analysis. And here we have the output, line count, word count, and character count, how much it is. Okay, so using subroutines, you can call a file as well. You can open the file. While it's not file means till its end. In of file, then do the lexical analysis, and finally output what is the character count, word count, and line count. Okay, multi-file word count. For the multi-file, what you are going to do is create a file list, traverse each file list using a for loop or something, then you have to output each time whatever you find in the program. So this is not much important. The important part is this one. This is the main logic. This one you have to remember. This is the main ingredient of this question. Okay, and what else do we have? See, this is a really long program. I don't think so they can ask in exam this much long, so you can skip that. Parsing a command line, that's also not important from exam point of view, just for your information. These things are given. And start states, nope. ISE code, source code analyzer, no. So if you basically just know what is the lexical analysis and how to write a simple program for Lex, that's all main things. A theoretical concept regarding what is v.Lex and all, what it does, that's all you need to know. Okay, in the second chapter. Coming to the third chapter, which is using Yacc. In the third chapter, Let me change the color, we keep it green, right? So this is the third chapter using Yacc. For the Yacc, the main thing is grammar. Okay, so let's see what is there in this chapter. See, this we already know, right? Statement name is equal to expression. Expression can be number plus number or number minus number. So in the place of this, either this will be substituted or this will be substituted. That's all. That's the grammar. So we need not focus much on this because we already know these things. Statement, expression can be this number plus number. Recursive rules, expression, number, and expression means and expression can be expression plus number or expression minus number or just a number. So in the place of this, I can write expression plus number minus number, or I can just write in place of expression number, so it will be number minus number, or it will be number plus number as well. So that's the recursive rule. Means what you have defined in the left part, same thing you are also defining in the right part along with some other thing. Okay, that is the recursive rule. Shift reduce parsing is important. Okay, so listen carefully what it is. In shift reduce parsing, if we just have to parse this one, Fred is equal to 12 plus 13. Fred is equal to 12, Fred is equal to 12 plus, Fred is equal to 12 plus 13. Internal stack one at a time. In shift reduce parsing, what happens is, here that thing was there. Yeah, here the thing is there. Okay, so what's happening here is 2 plus 3 into 4. So 2 will come, shift number, E, change it to expression, E plus, shift plus, then add number, means shift number, then change the number to expression. This is known as shift reduce. Okay, so let's go back. So by name itself we can define what is shift reduce parsing. You only tell me what is shift and what is reduce. You have an input here, 2 into 3 plus 4. Now tell me what is shift reduce. Shift here, reduce it to E, shift here, shift, reduce it to E, then shift here and reduce it to E. It will be as follows. That is known as shift reduce parsing. Okay, so like this expression can be again expression plus number, and this expression again is defined. So when you do shift, the numbers will come. When you do the reduce, it will means turn to an expression. Okay, that is shift reduce parsing. And yeah, that's pretty much it, what you need to know what is shift reduce parsing by using an example. Okay, you have to mention that it happens iteratively, one by one, shifting the tokens into the internal stack one by one, and then reducing it to expressions. Okay, so expression is equal to number plus number in that format. Okay, so it gets reduced to this much. Fred is equal to expression, then expression can be defined as expression plus another expression. This can be defined as 12, this can be defined as means another expression, right? E into E, this can be defined as E into E, then this will be 13 and this will be 4, so it will be 12 plus 13 into 4. You are shifting these things here and then reducing it to a single expression. That's what shift reduce expressions main content is. Okay, that's what you have to highlight in the exam sheet. Okay, then what we have, why Yacc cannot parse. So you can go through it if you are means if you like to know more about the internal working of Yacc, but this is not asked in exam. Okay, so I'm skipping for now. Okay, and Yacc parser, for that you need to have this one, token name number. Two tokens are generating name and number. So the rule section, see there is a ambiguity here. Okay, let's come to ambiguity later. First listen what it is. Name and number. Name and number are two tokens. Statement is equal to name equals expression or expression itself. So statement can be name equal to expression or just an expression. If it is a name is equal to expression or expression, I need to know what is expression, because expression is not a token, right? So I need to know what is expression. Expression can be number plus number or number minus number. Okay, that's what the rules part of Yacc program looks like. Have a token and define what is the grammar of it. Okay, and yeah, that's pretty much it what is mentioned here as well. And here what we have, name is equal to expression or expression. If it's of this form, then you have to output $1. Okay, $1 is the first argument. First argument means expression. That's all. This is the $1, and here also we have the things. This is $1, this is $2, this is $3. So expression is equal to expression plus number. So the final output will be $. This will be equal to 1 plus 3, right? So that's why we have written this as follows, and this is equal to 1 minus 3. That's why we have written 1 minus 3, and this is just a single number, so it is $1, and this will be the $$ value. Okay, that's how the rules part of Lexer works. Sorry, the Yacc program works. And here we have the Lexer, and what we have in Lexer. Okay, 0 to 9 plus or /t or /n dot, what all we have to do, that's defined here. Okay, if it's a number, then return the number. If it's this one, ignore the white space. If it's this one, return 0 because it's end of the file. If it's anything else, return that same thing. Okay, and running a simple parser, refer to the my lab videos. There I have explained arithmetic expression ambiguity. This is very important from exam point of view, very important. How does ambiguity arise? See here, if I take an example, this is the lab program, I guess one of the lab programs, not sure which one, but this is there in the lab program, evaluating an arithmetic expression, right? Let's see how an ambiguity arises. See here, if I just write like okay, let's discuss from here. 2 plus 3 into 4. So if you have not told the compiler any precedence, okay, like what is more important, plus should be taken first or into, you can do it in two ways. 2 plus 3 it will do first and multiply with 4, or it can do 2 or this one, right? It can divide in this way or this way. It's completely ambiguous, I mean, yeah, or this way, completely ambiguous, but answers we get as different. That is known as ambiguity. So that's the first means the answer to the question what is ambiguity, and by an example this you have to write. Okay, and how do you overcome is the second question. How do you overcome is you have to tell to the compiler this is first or this is first. How do you tell that? By associativity. This is known as associativity. Left means left associative, start from the left part. If it comes minus plus, do that, then do this. Okay, that is the associativity we have defined. And u minus is unary minus, just a simple minus. It has no associativity because it's just a single operator. Means minus 7, what other thing you can do with minus 7? Only one answer you will get, minus 7 only, right? So that's what is there here. And after you have defined this one, you will get the correct answer. Only one answer you will get. You have removed the ambiguity. That's what it's mentioned here in detail. Okay, you can go through it for means if you did not get what it tell. So yeah, that's what you have to remember. What is ambiguity? How to remove it using an example. Okay, variables and type tokens, not that important. So nothing, you are just using variables. Define some variables in the this section and fill those variables with some values in the logic part. Symbol values and star union, not that important. Symbol tables, we already discussed what is symbol tables. So here's some more information given, you can go through it. Just remember, symbol table is a table which has the symbol and the value pair, and we get the symbols when we parse the input string from the lexical analysis. We get the symbols and write some values. That's the second point. And after you have parsed that, you will be using these things for the reference purpose and assigning some values, and you are using it for referencing the addresses and all like that. You can write anything. So yeah, that's what you have to do in the exam if they ask you. Okay, what is about the symbol table, and if you read it and get more information, that's best for you. Okay, but if you don't have any idea, write like this only what I told. Okay, Lexer with symbol table. Yeah, we are just combining Lexer with symbol table so that we will retrieve faster what is the values. We need not search again and again. Functions and reserve words in symbol table. This is all just for information. These questions are not basically asked in exam. You can go through it if you want more information regarding the actual working of it. Building parsers with make. No. Okay, that's all what is in the module 4. So if we again go through the question bank which I had shown you in the starting of this video, you can easily get to know what are the things which are important. Syntax of Lex and structure of Lex and Yacc program, the definition part, okay, and the rule section, user defined section here. You know the main things in each of these main points, what it does, the functions of it, that's more than sufficient. The parts of speech program, what is symbol table, Parser-Lexer communication, difference between Lex and Yacc, Google it. Regular expression meaning, different regular expression like dot, star, question mark, plus, and so on. And Yacc program to identify the a power n, lab program 2, lab program 6a, lab program 6b, word count program, the number of words, the number of characters, number of lines already discussed. Shift reduce parsing, that's also we discussed by using an example, which is 2 plus 3 into 4. And what do you mean by eliminating ambiguity, that also same example you can give for defining this. Yeah, just focus on these things whatever I just discussed here. So mostly the questions are asked from these topics only, and that's all from my side for the module 4. If you got any doubt, you can send me in Instagram, and my link is in the description box. And make sure you like and subscribe, and that helps me in making more videos like this. And thank you so much for watching. I'll see you in the next one.